Mars Exploration Program. Mission Statement. The goal of the Mars Exploration Program is to explore Mars and to provide a continuous flow of scientific information and discovery through a carefully selected series of robotic orbiters, landers, and mobile laboratories interconnected by a high. NASA MEP is seeking feedback from the science community for its draft plan for the future of the program. MEP is excited to share this draft vision for the program's future, entitled Plan for a Sustainable Future for Science at Mars. The plan is intended to look toward the next 20 years and center on community-responsive science. Themes. The draft plan suggests a new strategic paradigm designed to send low-cost, high-value science missions to Mars at a higher frequency, develop new mission-enabling technologies, and address critical infrastructure at Mars. We are seeking community feedback at. The mission team is making sure the robotic scientist, now in its fourth extended mission, is staying strong despite wear and tear from its 11-year journey. For 1,000 Martian days after setting its wheels in Gale Crater on August 5, 2012. NASA's Curiosity rover remains busy conducting exciting science. The rover recently drilled its 39th sample, then dropped the pulverized rock into its belly for detailed analysis to study whether ancient Mars had the conditions to support microbial life. The rover has been gradually ascending the base of 3-mile-tall, 5-kilometer-tall Mount Sharp, whose layers formed in different periods of Martian history and offer a record of how the planet's climate changed over time. NASA Science Mars Exploration Program Skip Navigation News November 6, 2023. NASA's Curiosity rover clocks for 1,000 days on Mars. Zoom in, zoom out, go home, toggle full page, toggle full page. Curiosity's navcams view the area around Sequoia. NASA's Curiosity Mars rover captured this 360-degree panorama using its black and white navigation cameras, or navcams, at a location where it collected a sample from a rock nicknamed Sequoia. Credits: NASA JPL Caltech. Download image. To interact, use the controls in the top left or pinch to zoom in and out of the image. Click or touch and drag your cursor to move around in the image. The mission team is making sure the robotic scientist, now in its fourth extended mission, is staying strong despite wear and tear from its 11-year journey. For 1,000 Martian days after setting its wheels in Gale Crater on August 5, 2012, NASA's Curiosity rover remains busy conducting exciting science. The rover recently drilled its 39th sample, then dropped the pulverized rock into its belly for detailed analysis to study whether ancient Mars had the conditions to support microbial life. The rover has been gradually ascending the base of 3-mile-tall, 5-kilometer-tall Mount Sharp, whose layers formed in different periods of Martian history and offer a record of how the planet's climate changed over time. Curiosity views Sequoia using its mast cam. NASA's Curiosity Mars rover used the drill on the end of its robotic arm to collect a sample from a rock nicknamed Sequoia on October 17, 2023, the 3,980th Martian day, or soul, of the mission. The rover's mast cam captured this image. Curiosity views Sequoia using its mast cam. NASA's Curiosity Mars rover used the drill on the end of its robotic arm to collect a sample from a rock nicknamed Sequoia on October 17, 2023, the 3,980th Martian day, or soul, of the mission. The rover's mast cam captured this image. Credits: NASA JPL Caltech, MSSS. Download image. The latest sample was collected from a target nicknamed Sequoia. All of the mission's current science targets are named after locations in California's Sierra Nevada. Scientists hope the sample will reveal more about how the climate and habitability of Mars evolved, as this region became enriched in sulfates, minerals that likely formed in salty water that was evaporating as Mars first began drying up billions of years ago. Eventually, Mars' liquid water disappeared for good. The types of sulfate and carbonate minerals that Curiosity's instruments have identified in last year help us understand what Mars was like so long ago. We've been anticipating these results for decades, and now Sequoia will tell us even more, said Ashwin Vasavada, Curiosity's project scientist at NASA's Jet Propulsion Laboratory in Southern California, which leads the mission. Deciphering the clues to Mars' ancient climate requires detective work. In a recent paper published in the Journal of Geophysical Research, Planets, team members used data from Curiosity's chemistry and mineralogy instrument to discover magnesium sulfate mineral called starkite, which is associated with especially dry climates like Mars' modern climate. The team believes that after sulfate minerals first formed in salty water that was evaporated billions of years ago, these minerals transformed into starkite as the planet continued drying to its present state. Findings like this refine scientists' understanding of how the Mars of today came to be.